Hey Algebra class, it's Miss Curvan again, and we're back. We're still working with linear combination or elimination, but the problems that we looked at yesterday were kind of nicely lined up for us, and today we're going to look at what happens maybe when the problems aren't quite so nice. So for our objective for today is we'll be able to solve systems of equations by linear combination using multiplication and then addition. So let's go ahead and recall the process that we learned yesterday. You'll remember that we had a series of steps and they worked really well when either the x coefficients or the y coefficients were opposite. And then they would cancel each other out. But what about this example that we have right here? The system given is 3x minus y equals 8, and then x plus 2y equals 5. Now remember, step 1 was to line up your x's and y's. And of course, step 1 is great here because our x's are lined up, our y's are lined up. That's fine. But remember, step 2 was you want to have opposite coefficients. Remember, coefficient is the number that's in front of a variable. And we do not have opposite coefficients here because our x coefficients are positive 3 and positive 1. And our y coefficients here are negative 1 and positive 2. So what are we going to do? You're really smart, I'm sure. You have probably realized that if we would multiply this top equation by 2, which is where this is coming from right here, then we would have opposite coefficients. So let's give it a try and see what happens. I'm going to just cover some of this up. So we're going to multiply by 2. And remember, we're going to use distributive property here. And it's like Mario. It's going to jump. The 2's like Mario. It's going to jump on everything. We're going to end up with this new equation for the top. So this equation becomes this equation because 2 times 3x is 6x. 2 times negative y is minus 2y. 2 times 8 is 16. So we have this system now. And oh, now look, isn't this wonderful? Now the y's do have opposite coefficients, negative 2 and positive 2, and they'll cancel out when we go to the next step. Now we're going to go to step 3, where we add the two equations together by adding down the columns. 6x plus x is 7x. Remember, we purposefully did this so that these would cancel out, so we shouldn't have any y's, and we don't. And 16 plus 5 is 21. Step 4 is going to be to solve for the variable, in this case x. We're going to solve for x by dividing both sides by 7, and we get our answer for x, that x equals 3. Remember, this isn't our final answer because we're looking for a solution of a system of equations, so we need an ordered pair. Let's go on to the next step. I'm going to put a little shade up again here. We only need a little exposed at a time. Remember, from the previous page, we had found that x equals 3. So we need to figure out what is y when x is 3. Step 5 would be to substitute this x value back into an equation to solve for the other variable. So we know that x is 3. We're going to substitute that in here, and we can figure out, well, what is y then? So that's how we get this 3 plus 2y equals 5. We're going to solve for y by subtracting 3 from both sides. We get that 2y equals 2. If we divide both sides by 2, we get that y equals 1. And then we're going to write the solution as an ordered pair. Solution is 3, 1, 3, 1. Step 7, check your solution as it was yesterday by substituting it back into both equations. Because remember, we're solving for a system, so we want a point that makes both equations true. The top equation will give us 8 equals 8. That's true. And the bottom equation will give us 5 equals 5. That's also true. What I'd like you guys to do now is try another one, which is going to be on the top of page 2. Pause the video, give it a try, and come back. Okay, class. Hopefully you're back, and hopefully you've noticed that step 1 is taken care of since our x's and y's are lined up, but we do not have opposite coefficients. So what are we going to do? Hopefully you decided, as I did, that if we would multiply the top equation by 3, then we will have opposite coefficients, because if we multiply this through by 3, we'll have a positive 3y here, and we have a negative 3y there. Let's go ahead and do this. Multiply by 3. Remember, we're going to distribute it, so the 3 has to be multiplied by everything in that top equation, which is how we get 3x plus 3y equals 15 as our new top equation. And we can now go ahead and add the two equations together by adding down these columns. Remember, we purposely did this so that the y's would cancel out. So we add down, we get positive 8x equals positive 32. Going to go ahead and step 4, solve for the variable, which in this case is x. If we divide both sides by 8, we get that x equals 4. We can now go to our next step. Again, I'm going to put the little shade up. Remember, we found that x equals 4. Step 5, we're going to substitute that x equals 4 back into one of the equations and solve for y. So when x is 4, we have 4 plus y equals 5. We subtract a 4 from both sides, and we find that y equals 1. Our ordered pair, that's our solution then, is 4, 1, 4, 1. Our final step is to substitute that point 4, 1 back into both equations to be sure that they are true. And we'll find that when x is 4, y is 1, 4 plus 1 is surely 5. 5 times 4 is 20, minus 3 times 1 is 3, which is surely 17. 20 minus 3 is 17. So this point does make both equations true. It is a solution for the system. If we graphed both of these lines, we would find that they had a point of intersection at the point 4, 1. What I would like you guys to do now is to try something slightly more complicated. Let's talk about this one. We have no coefficients that are the same. And what we're going to do here is decide which variable we'd like to eliminate. So I'm just going to say y. I'd like to eliminate y. How can I do this? What I'm going to do is, if I notice that I've got a 3 here and a 4 here, well, if I multiply the top equation by 4 and the bottom equation by 3, let's see what happens. Oh my gosh, look at this, it's magic. Because remember, we use distributive property. 4 times 2x is 8x. 4 times negative 3y is minus 12y. 4 times negative 1 is negative 4. We also are going to have to distribute the 3 here to the bottom equation. 3 times 3x is 9x. 3 times 4y is 12y. And 3 times 24 is 72. Would you look at this magic? What just happened here? Now we do have opposite coefficients. We've got a negative 12y here and a positive 12y there. Now we can proceed just like we have been since yesterday, and we can go ahead and solve for x, because when we add our two equations together, this column with the y's cancels out, and we only have x's now. We can solve for x, getting x equals 4. We can solve for y. We get that y is 3. The solution here is 4, 3. And of course, you would check this by plugging 4, 3 back into both of these equations. What I would like for you guys now to do is to try, there are 4 problems on the back. I want you to do those as independent practice. Bring your completed packet to class tomorrow, and if you have any questions, be sure to write down those questions and bring them to class. See you tomorrow.